Yeah, so welcome back. Now we will see how to run the code. The most easiest part and the most difficult part of this video. Because once you will understand what we are trying to do, you will understand anything else. For classification, what we are basically doing is on basis of several columns that we have, we will select several columns over here. And on basis of that column, we will try to predict whether the transaction is fraud transaction or not. And it is a very great idea and a very great concept to work with. Although the problem with this dataset is that there are around, I guess, 900 or so, or maybe less than that, transactions only which are actually fraud transaction. Rest all are not fraud. And this is a very general real world scenario. We don't have a lot of fraud transaction. Otherwise, the government will only do something like they will be taking a lot more bigger actions for it. But we are having very limited number of fraud transactions. Out of lakh or 10 lakh transactions, we get around 100 or 200 fraud transactions, or maybe less than that. But still we get the fraud transactions. So we have to make sure that we make a mechanism to consider those fraud transactions. I would love to explain you machine learning models, and maybe I make a separate playlist for that. But if I do that in this video itself, it will take a lot of time. So if you know the basic, I would say just a very basic intuition about machine learning models like logistic regression, you can still be able to grab what is going on in this particular session. If not, then also I will make sure that you understand, but still I would suggest that at least at once go through all the machine learning models like linear regression, logistic regression, then we have the polynomial quadratic equations like quadratic regression kind of thing. Just try to explore a bit on your side, and I may start a separate series for machine learning. Depending on how many views I get on this series, I will decide it. Otherwise, I will continue this series first, and then I will probably make in future. So yeah, for that time, I assume that you already know some basics of machine learning. You at least know what is classification. That is also fine. So for classification, we are using the logistic regression over here. And as I've told you, in the Spark, we get the ML library to work with the machine learning models. Unlike we use sklearn in our traditional Python notebooks, we are going to use the PySpark only to get the machine learning models. We'll start by importing the functions which are columns and UDF. UDF, my user-defined function, which we will see in use just after some time. Then we have the features, and over here from the features, we are importing the string indexer, which will convert the string into a numeric index. So suppose you have a column having value as gender and male. What string indexer will do is, it will convert the whole column from gender to male to 0 to 1. So for 0, it's male, for 1, it's female. So just a simple technique which we use as we cannot work with text when we process the data, and we have to take some numeric values. And so we use this very clever technique of converting the categorical variables to a numeric variables. We have vector assembler, which is basically going to combine several columns into a one single vector. So instead of now taking 100 columns into consideration, we are only taking one single column having 100 values. Okay, so we'll see in that also into the action. And then we have the standard scaler. What it will do is, it will convert the whole data frame that we have into a zero mean value and a unit variance. That means your data set will be between -1 to 1. That whole frame will be between -1 to 1. And we will see that also in detail. And you can also, if you can see that I've opened the Grok chatbot over here, which we will use to understand the whole code. Because for me to explain, I might miss something, or for me to explain, I might not know something. That's why using a model is not a shame in 2025 at least. So scalar will basically make the mean 0 and make the variance unit. Okay, unit means 1. Then we are going to use the ml.classification library, and we are going to install the logistic regression. Then we are going to use the evaluation function or library, and from that we are going to use this binary classification evaluator function. We are going to import the pipeline, and we are going to import the float types over here from the types, and we are going to import the matplotlib. So initially I told you guys that in my compute, if you will go, you will see that we have installed the matplotlib over here. If you will not install it, it will not work. Coming back to my file right over here, it will take some time to load. Probably my 2 hours are going to end pretty soon, so I have to create the cluster again, but that's not an issue. This notebook will still be saved, okay? So you can connect the notebook with the new cluster that you create if you fell into this issue. So yeah, we process the data, and now we are at this moment where we apply the machine learning model, and we are talking about this matplotlib. So we also installed it. Now we will understand each code line by line, and we will take the help of Grok to understand it. The first code over here says that we have created a function as get class 1 prop, and we are returning the floating value of prop1. And over here we are defining a user defined function as get class 1 prop, and we are assigning as a float type. And this is my function, which is get class 1 prop UDF. Okay, so I have created a user defined function which is like something like this, and let's see what this function is going to do. So over here, first is my user defined function which I have created over here. So what this is going to do is basically the model outputs a probability vector. This will be creating a probability vector of chances of not fraud or a fraud. Suppose you pass a value to it, so it will give a probability vector that there are, let's say, 0.8% chances of it to be not fraud and 0.2% of chances of it to be a fraud. So where 0.8 is the chances of not fraud and 0.2 is the chances of fraud, that is class 1. And since this function extracts the fraud probability, we are only going to talk about the index 1 over here. So we are only going to talk about the chances of it to be a fraud. Okay, so class 1, not class 0. Because for a class 0, we don't care that it's a not fraud transaction. What we worry about is that whether it is a fraud transaction. So understand that I'm giving a quick kind of intuition of what we care about. Suppose you are making a machine learning model to predict the cancer or the chances of cancer. So what you want to predict? Whether that person will get a cancer. So this should be more accurate, or whether a person is not having a cancer. This should be more accurate. Think again. You want to make a machine learning model and you want to check whether a person is having a cancer or not. So where should I get more accuracy? Whether that person is having a cancer in that particular domain or whether that person is not having a cancer. Well, if I try to predict wrong values for a person not having a cancer, it's fine. But if a person is having a cancer and I predict that thing wrong, then it's a thing to concern about. And we'll talk about that using false negatives, true positives in our classification table that we create. Confusion matrix. But for now, we are not going to look into that. We are just going to look into our user defined function. So it will basically extract the fraud probability. We will use this in our ROC curve, which is a curve that we make to basically get the area under the curve, which will be helpful for us to basically find out the accuracy for this particular model, which needs the probability of the fraud. Okay, so although these functionalities are not really great to understand, still, like, you don't have to understand this code. You can basically use this overall in all kinds of models, but still you should get an intuition what we are trying to do. Registers the function so PySpark can apply it to every row in the data frame. So we are basically registering this function and later on we are going to use it. That's great. Now let's see what we are doing over here. We are basically converting our data frames, which I created in this right over here. Cards, not cards count, DF cards, DF users and DF MX transaction. So since I have not closed this Spark session, I can use this data frame in my different cell over here. So I'm going to convert this data frame as users, cards, and as MX. So what I'm doing over here is that I'm creating a new data frame where I'm joining my transactions and cards. So how can I join my transactions and cards? In my transactions file, which is MX filter transaction file, I have the card ID, and on that I can apply the join. So I hope you know the basic SQL joins. Over here, the MX will be having this card ID, and the card will be having its unique ID, which is also going to be a primary key as ID. And on that, I'm applying left join. So all the values inside this will be there. And apart from that, I will also get all the values inside my cards as well. If there is a value or a card ID present in the MX, which is not present in the cards ID, although this is not going to be a case, still if that happens, for all the remaining rows that I have in the card ID, it will assign those rows as null. If you are still not able to understand it, make sure that you understand the basic SQL, although it's of no use once you understand the lines that I'm trying to say, because we will make a SQL query generator as well in the upcoming videos, so that our business analyst or our end user manager or someone else can perform the queries or ask questions regarding our dataset and get the answers of those questions, rather than being depending on a person to answer the questions. Now we are also going to select some particular columns over here from the transactions ID, which is my ID of transaction, client ID, amount, fraud label, which is going to be yes or no value, and MCC code, which is again industry code that is assigned by the card brand, or over here our bank is assigning it. It's a unique ID for different kinds of businesses to whom my client is going to pay. Then we are going to add the user's data to this new data frame, which is df temp, which is my temporary data frame. So I'm going to create a new data frame over here as combined data frame. And in this, what I'm going to do is I'm going to put a join between client ID and user ID. And I'm going to again put a left join just like I did over here. This time I'm going to select transaction ID, client ID, amount, fraud label, and all other remaining variables of our interest for this particular analysis. Then I come down over here, and what I see right now as a fault or something like that, I can say is I can add more columns to this. But since I've already added the columns right over here, I don't need to do it, but I can do it. So yeah, we have this. Right now, we only have this many sets of column. From the cards data, I can also add I can do it over here. From the cards data, just like I did over here, I've got the user's detail. I can get the detail of the credit limit as well. So here I can pass the credit limit as well, because credit limit can also be a factor of our interest over here. We have also not added pin change due and other variables, as you can see over here. But let's just not take this thing right now, but we can. And your homework is to basically take these values as well. I have left it for you. Make sure you take those columns over here. Or let me just take this credit limit, and for all other columns, I leave it on you. So just like I've take this value over here for the card, which is my credit limit. Now this credit limit will be stored in my df temp. So over here, what I'm going to do is I'm going to also add this new column, which I fetched credit limit, into my df combined data frame as well. It's not really hard to understand, guys. Still, I know sometimes it get a real bit overwhelming when you see such a large number of lines of code. But yeah, that's what I have done over here. I have basically applied the joins over here, and in the end, I get this new data frame with only these many values, And yeah, after that, I can also get this value over here, which is my credit limit. And yeah, that's it. You are basically assigning the list over here with the categorical columns. Since my MCC code is having only 108 values, and it's a categorical column over here. Gender is going to be a categorical column. Retirement age is going to be a categorical column. Whereas my amount, current age, per capita income, and all other variables are of type numeric. So those are my numeric columns. So as said before, for our categorical columns, we are converting those columns into numeric type. Coming back to this explanation code, we have already applied the joins on the data frames. So we'll not look that again. This is my categorical column and this is my numerical column. We already saw that over here. We have done that. We have defined our features basically, which we are going to use to analyze. Although we can analyze more features from cards table, which we have not added, like pin change due, which was yes no value, whether the pin is changed in last 2 years or not. Although we have kept it as 7 because this data was last updated 5 years ago. So in total, we are checking whether the card was updated, pin was changed in last 7 years. But in general, we are basically trying to calculate whether the card pin was changed in last 2 years. We have not taken that variable over here. We could have taken, we could have taken that, but we are not going to worry about it for now. You can do it on your side. Although you can see one thing, it is terminated now. So yeah, you will also face this kind of issues. All you need to do is you need to go to this compute over here and you have to delete it. You can't reuse it. You have to delete it. You have to create a new compute over here and just click create compute. It will take from 1 to 2 minutes to 5 minutes to 10 minutes as well to do it. Regardless of that, we will come back to our workspace, and don't worry, your data will be also stored in this. You don't have to again upload your data. It will be stored in the file stores/tables folder. But it is not connected, so you can't basically run your code now. So we'll wait for some time. We will first assure that we are connecting with this new cluster. We'll confirm it. Although it says that it is now starting, it is not active yet, but we will wait for it to start. And make sure that you also have to rerun your cell in order to rerun the Spark session, because we now don't have anything on the new computer that we are creating. So we have to run the above code as well. Regardless of that, we will look in the below code, and yeah, the notebook is still working fine. We have assigned our categorical and numerical columns. Now we will see what my indexer is going to do. So basically, as I've told you earlier also, we have the categorical columns as string, but our computer or our model will not understand the strings. So what we will do is, suppose we have 5 rows over here, 5 columns over here. Not 5 columns, what I'm saying. Suppose we have 5 categories over here. As for card brand, we had 4 categories as Amex, Discover, MasterCard and Visa. So instead of naming that as Amex, MasterCard or Visa or Discover, I'm going to name that as 0, 1, 2, 3, 4. And yeah, that's it. Suppose we have a categorical column as gender. Over there, we only have 2 values. So we can apply the binary encoder to binary indexer to basically get the values as 0 and 1. We can do the same thing for MCC code, but over here we will have the values from 0 to 108, because in total we have 109 unique MCC codes. And like that, for retirement status, we are only going to consider 2 values, which is 0 for retired or 1 for not retired. And yeah, that's it. For the numerical columns, you don't have to do anything. We'll keep it as it is. Now let's see the code. Over here, we are basically creating the indexer. In string indexer, we are passing the input column as column. So this will be my column. Output column will be as column as well. And since we are taking the categorical columns over here, we are basically passing each categorical column using this for loop. So what this for loop will do is, it will fetch the column, which is in the categorical column, initial column will be MCC. So what it will do is, it will fetch the MCC, pass that MCC as input column. Output column will be column, that is MCC plus I will pass as index. So the new value for my output column will be MCC/index, and it will contain the value 0 and 1, not 0 and 1, from 0 to 108, because in total we have 109 unique categories over here. Similarly for gender, this for loop will work, and now my columns will fetch gender over here, which is my second value, and over here the gender will be assigned to input column. Output column will be my gender plus index, which will be named as gender/index. Okay, not /_index. So gender_index will be having the value as 0 and 1, assigned for male and female. Similarly, for my last value over here, which is retirement status, this column will be fetched and passed to the input column, and the string indexer will again do its magic and convert the string into numeric values, and the output column will be of name as retirement status with underscore, and then again underscore index. That's it. After that, what I'm going to do is, just like I did it for my features over here, my output column, which is my, I would say, the column which I'm going to predict fraud labels. Fraud labels are also of type string. So I also have to make sure that I convert those into numeric values as well. So I will create a fraud indexer over here, and I will say that string indexer, input column will be my fraud label, output column will be my label, and I will keep handle invalid keep. So if there is something which is invalid, a character which is invalid, so it will also handle it. Don't worry about it. Keep it like handle invalid equal to keep. And yeah, voila, that's it. It's done. You have indexed your columns, your numeric columns, your string columns into numeric. Okay. So basically your categorical columns are of type numeric now. So you can analyze. And that is what said over here. Suppose you have male, so it will convert it to 0. If female, it will convert into 1. Similarly, for my fraud indexer, the fraud label will be yes or no. It becomes 0 or 1, which is my target variable of interest. So fraud label is my target variable as I'm going to predict fraud label. Handle keep, if there is unknown data, it will assign a special number instead of crashing. Okay. So yeah. Adding weights. So now this is a machine learning concept. Still, I will explain it because it's really important. In the starting, I said my data is not distributed equally, because how distributed equally? My fraud labels are not distributed equally, because in real life, it's not like out of all transactions, 50% transactions are fraud and 50% are not. If that would be the case, no one will use the online transaction. So there is a very limited number of transactions which are actually fraud in real world scenario as well. And in our data set also, we see the same thing. So when our machine learning model analyze the data, it will focus on both of the things, which is my not fraud transaction and fraud transaction. But since I will be having more transactions with a label of not fraud, it will try to focus more on those values than on the actual fraud values. So I have to make sure that my model panelizes the transaction or give more importance to the transactions that are having the label as fraud, which is yes value. So for that, we will give more weight to those transactions. How do we do it? It's a very clever maths only. Let me first show you. Over here, we are basically doing this. Okay. Now, first thing is that we are label counting. Over here, we are counting the fraud labels. And then we are counting the total number of transactions that we have. So coming back to the code over here, you can see fraud is rare. If 99% of transactions are not fraud, the model might guess non-fraud transaction every time, which is simple to understand. Assign weight. Rare classes like fraud get higher weight to make them more important. So what we are trying to do is count how many times fraud label appears. So basically we are going to count how many times our fraud labels, which is my yes or no, are appearing. Suppose my yes is appearing for 20 times and my no is appearing for remaining 80 times. Okay. So what I'm going to do is my weight will be the total number of rows. Let's say for fraud transaction, it is 20 divided by count of class. Okay. So it's like fraud are very few, gets a big weight. Okay. So suppose my total number of rows are my total number of transactions. Okay. And count of class is like the count of how many times I'm getting the transaction as fraud out of the total number of rows. Suppose in 5 lakh rows, I only have 100 transactions as fraud transaction. So if I divide the 5 lakh by 100, I will get a number like 5,000. But for the transactions where I don't have the transaction as fraud, the fraud label is basically no, or I don't have this transaction is not fraud. Okay. So for that particular case, the count of class will be more. I will be having more of such transactions. So out of assuming that we have only 100 transactions which are of fraud, so for the total number of transactions, which will be 5 lakh, I will be having the remaining 4,99,900 value as fraud or not fraud. Okay. So when you divide it, you will get a very smaller value for the weight. So for the for the category that is coming for less time, I will get a more weight, and for the category which is getting more time, I'm getting less weight. Am I correct? Yeah, I am correct. So even if you are not able to understand this, I would suggest you to please pause it for a while and try to understand it. So what we are doing over here is that we are basically assigning a new column as weight to my DF combined data frame, and this weight will have the value as total number of columns in total, which I got from here. It will be 5,77,000 or somewhat like that values. So that value. So that is my total number of transactions that I have in my DF combined. So the total number of rows that I have in DF combined. And I will create a new column as weight, and this weight will be having a value as total number of transactions divided by call count. So call count is how many times I'm getting the value as no, whether the transaction was fraud or not. And then I'm going to select the fraud label, and then I'm going to assign the column as weight over here. So what this whole thing is going to do, it will assign two weights over here. First weight will be for transactions which are not fraud, which is going to be really, really small. And other weight, which is going to be really, really big, will be assigned only for those transactions which are fraud. And by doing that, I'm going to penalize the transactions which are fraud more than the transactions which are not fraud. Okay. So watch it for a while, you'll understand it. That's what I can say right now. So this is my label weight. So I'm going to add this label weight over here, which I created right over here. And in that, I'm going to also add the fraud label, which is my fraud label. And I'm going to basically join this with the left. Okay. So after doing it in my DF combine, I'm basically combining a new column, which is going to be label weights. So over here in the label weights data frame, we are creating this with two values. So the first column will be my weight. Second column will be my fraud label. So for yes, what is the weight? For no, what is the weight? And then I'm combining this with my data combine. So basically this is my data frame, and I'm combining these this particular I would say data frame on the condition of fraud label, because we have fraud label in our label weights as well, and we have the fraud label in our DF combine as well. And I'm combining it with the left join. So yeah, that's how I will combine the weights with the DF combine file. So how this file will look, so let me explain that as well. So in the end, what this file will look, I will have all the DF combined rows. I will have fraud label, which will be yes or no, and then I will have weight. I hope the spelling of weight is correct, and yeah, indeed it is correct. So I will be having different values for credit limit, yearly income, everything like that. And for the fraud label, I will be having, let's say, no. Similarly, for the fraud label, I can have yes. So for the yes, if the transaction is fraud, I will have a big number, a big fat number for weight. But for the no values, I will be only having a very small number like 1.2 or something like that. So now you understood, I hope you understood the use of weight and why do we use it. Okay. And that's how the final file will look like, or the final data frame will look like. After that, we are using the assemble the and scale the features. So yeah, what I'm going to do is I'm going to assemble, basically create a new data frame as assembler inputs, in which I'm going to pass the column and index from the categorical columns. And along with that, I'm also going to select my numerical columns. So it's nothing, guys. Remember earlier we used string indexer in our code right over here. And we assigned the new column name as column name / index. So MCC will be converted into MCC index, but the values instead of 1, 2, 3, I don't remember what were the values for MCC code. It was not like, it was 4-digit values, 4-digit unique values for each MCC code. But now it will be like 0, 1, 2, 3 and so on. Similarly for our gender, it will be 0 and 1. Not for gender, but for genders underscore index, the values will be 0 and 1. Similarly for retirement status underscore index, the value will be 0 and 1. So what I'm doing is I'm basically getting those columns. So again, we are doing it. And then we are also adding those columns with the numerical columns. And all these columns are now stored in this new data frame, which is my assembler input. And what my assembler is going to do is, it's a vector assembler. It will pass this assembler input in the input columns, and the output column will be my row feature. So what I'm doing is, I'm basically creating a assembler, a vector over here. And what this vector will do is, it will basically convert my 7 or 8 columns into one single column of interest. So after that, I'm going to apply this standard scaler over here. The standard scaler will convert my values and will convert those values between -1 and 1, so that the mean will be 0 and the variance will be 1. Let me explain you what we are doing over here. See, vector assembler over here will combine all the features, example MCC index, amount which we had in the transactions initially, into one column as raw features. So it is creating a new column as raw features, which will be a vector like 1, 2, 100. Like why 1, 2? Because for all the numeric, all the categorical variable, I got the numeric values. And let's say 500 for the yearly income, 45 for the total debt. And like that, all of my column values will be combined into a single vector like this, which will be assigned the name as raw features. So now I only have one column, which is raw features, which will be having the values as the whole values, 1, 500, 45, and all other values that I have. Like for all columns, it will be combined into one. Like for all column values, it will be combined into one. And this is what we know. This is what we call it as vector assembler to do this thing. After getting this raw feature, I will be passing this feature into standard scaler as input column. The output column will be my features. I will put with standard true, with mean true. So what this standard scaler is going to do is pretty interesting. It will basically convert the whole thing with mean as 0. That means the center data will be 0 and standard as 1. So scales it to big number. Example, income does not dominate small ones. So we'll get a new output as features. So this will be my final, I would say, data, which I will be using with my machine learning model, which I call as the detective to predict a fraud transaction. So over here, we are going to use a logistic regression. Logistic regression is a classification model where we are trying to predict the classes as yes or no. Okay, for a binary classification model. So in the logistic regression, you can see, I can show you the code again over here as well. You can see we are passing the feature columns as features, which we fetched from here after applying the standard scaler. The label columns will have the label, and I guess we assign the label over here. Yeah, this is my output label, which is again string indexed using string indexer, and we have string indexed our fraud label file, which is now as label. So we are passing that as well, and this will be having a value of 0 and 1. And then we have the raw prediction column, which is going to be my predictions. So, oh no, sorry. So then we have the weight column. Okay, so as I've told you earlier also, we are going to assign the weight. So where we created the weight column, we created it over here. So this is my output weight column. Okay, so for yes, the weight will be slightly higher. I mean very higher, because our data set is almost like all values are, all transactions are not fraud, and there are only very few transactions of type fraud. Then we have the max iterator. Again, these are the parameters that we use. Then we have reg param, which is 0.01. And after creating this logistic regression model, we are going to create a pipeline to stage all of our above task, which is fraud indexer, assembler, scaler, and then we have LR, which is this one. So what it will do is, this pipeline will basically first initiate this step, and then we are going to initiate the assembler, then the scaler, and then the LR. So that's why we have assigned it like this. So this pipeline will execute all of this step by step. Okay. We are going to divide our data into train and test, because see guys, if you make a machine learning model fully on your test data, fully on your data, how will you test its predictability? Like if you give whole data to it, how will you know how effective that data is? So we will divide our data into 80-20%. Suppose out of 5 lakh values, 80% would be around 44 lakh values, and the remaining 1 lakh values will be my 20% of the data that I will keep as it is to analyze or to test the model's performance. So I will split the data into train data and test data. And for that, we have the random split function in the Spark. And I want to split it with the 80-20 ratio. And this seed over here is basically really useful, guys, because after putting this seed as a random number, it can be anything. It can be this number as well. It can be what it was, like 24. So on basis of that, what will happen is 42. On basis of that, what will happen is even if you try to run this code and it's a random split, still with as you are going to put this seed as 42, you will get the same output as I am getting. Okay, so that's why we use this seed over here as 42. Otherwise, you will get a random answer because you are going to randomly split the data. So you might get a different model performance and I might get a different model performance. So to make sure that the model is reliable across everyone's perspective, we are using the seed over here. Then we are going to fit this data into this pipeline, which is my trained data. I will be making the model. And then we are going to transform the predictions for the test data. So since we want to analyze the performance of this model, we are going to check it for the test data. We are going to use the binary classification evaluator, and we are going to pass the label over here and the predictions over here as well. The predictions which we are getting from here, model.transform test data. Okay. After that, we are going to name this metric as area under curve or ROC, and I'm going to basically get the AUC over here, which is evaluator.evaluate, and then I'm passing the predictions which I got from here. So AUC will be my area under curve. ROC is again a metric that we use to analyze the model's performance. To make the ROC, you can get the AUC value over here, area under the curve over here, and yeah, area under the curve will help us analyze the model's performance. But there is also one more thing called as confusion matrix. So what confusion matrix will tell us is how our model is good at performing the analysis, which is like how it performs to analyze the fraud transaction, how much good it performs to analyze the not fraud transactions. So over here, we are going to talk about true negatives, false positives, false negative, and true positive. Right now, I know you might not know what is of confusion matrix, although this is a part of machine learning. Still, I will explain. Coming back to the code, we created a pipeline, we performed we made the machine learning model, and now we are basically doing the predictions on the machine learning model that we made, that we named as model. We evaluated the model and we stored the value of area under the curve, and we applied the model to the test data to check its performance. So here the area under the curve, the AUC and the ROC are for the test data only. So to check the performance, you can't check it on your trained data. Trained data is already performing well. So the best way to check for the performance is to check for something that is not given to the model, to our machine learning model. And since we only gave the trained data to our model, right over here you can see, we are going to pass the trained test data to check for the performance. Okay. So the confusion matrix, as I was saying, is made for the test data. So confusion matrix will be created. I will not tell you the steps because it's just a simple code. You don't have to do this, to be honest, but still in Spark you have to. In this we get true negative. What is true negative? True negative is non-fraud predicted correctly. So negative is for the fraud. Okay. So I correctly predicted not fraud. So that is true negative. I correctly predicted the fraud, which is true positive. Okay. Fraud caught. I correctly, or I would say if false, I was not able to correctly predict the fraud transaction. Okay. Not fraud predicted as fraud. So I was not able to correctly predict the fraud transaction. Similarly, false negative will be I missed the fraud transaction. I tried to predict fraud transaction as not fraud. I know this is something like even after reading, I was not able to understand initially. So what I will tell you is give some time to this 4 lines, as it is really confusing to understand. Right now also, after making, I would say almost 5 to 10 projects and helping my other friends as well around the logistic regression projects this quarter. He was in a different department, although he was in auditing department, but still he got a logistic regression model to work on a data set. So for that also I explained him what is confusion matrix, and that's why this matrix got a name as confusion, because it is really confusing to understand it. but give some time and you will understand this four values over here. And what we care about over here is that what is my model's efficiency in predicting the fraud labels. So this will be my confusion matrix that I make over here using by calculating these four variables over here. You can try it by your side. I will not force you. But what it is trying to do is it is calculating basically whether the row was labeled as false, means the transaction was not fraud, and it predicted whether the transaction was not fraud. That means it's a true negative. If the transaction was not fraud and the prediction was transaction was a fraud, then it's a false positive. If it predicts the transaction as not fraud, but it was indeed fraud, then it's false negative. And ultimately in last we have true positive when the transaction was fraud and it predicted it as fraud. And then we get this confusion matrix. I know it's a bit confusing, but give your time. It is not that confusing as well. You can understand it. Now for plotting the ROC curve, again, we don't need to do it because, this is something like you just have to read the code and understand what is going step by step. But it is not necessary as well at the same time, because nowadays most of the libraries do it for you. So although I have kept the code for you to understand, but still it's not necessary. Basically, what I'm doing on the step 10 is I'm creating the ROC curve over here using matplotlib. So since my new cluster is created, I'll make sure that I install the matplotlib over here in this cluster as well, since you can see it is not installed yet. So what I will do is I'll go to my PyPy library, PyPy over here, and I will type matplotlib exactly as it is. You can also assign the specific version with equal to, but I don't want to do it. So I've named the library that I want to use and I've put it over here, which is matplotlib. Wait for some seconds or maybe a minute and it will be installed, as it is not a very big library to deal with. It's installed, and now we'll go back to our notebook over here and make sure that this notebook is connected with the server. Since this is a new cluster, I will again rerun the code over here for the pre-processing to initiate my Spark session and all those data frames that I created and used in my machine learning model. So I use the DF users, I use the DF MX transactions over here. You can see I've used these three data frames in the machine learning model as well. So I'll wait for some time till it processes all these data frames to get the columns ready for the analysis. Like what we are doing over here, we are removing the $sign and we already talked about it. So just wait for a couple of seconds or minutes and it will be executed. After that, if we will run this code, since we understood each line of code, in the end we are basically using the matplotlib, and in this we are plotting everything. We are putting it as false positive rate. What is false positive? False positive is when the label was not a fraud, but it predicted it as a fraud. And then we have the other thing on the Y as true positive rate, which is when the label was fraud and it predicted the fraud. Okay. So now take the name of the gods you believe in and run the code. It will take some time, but yeah, it should definitely get the error, and it got it. Oh, so I believe this error is because I have not put it as cards over here. It should be cards, not card. Okay. Just a very small error. Still, hopes are high. And let me just fly. I don't know what I'm making right now, but yeah, my English is great. I have a great poetry skills as well, thanks to ChatGPT. Again, wait for some seconds to let the model run. And let me just show you what it is doing over here. Spark jobs. So it is dividing this whole task into jobs and it is doing it. It will take some time. Wait for that. And let the model run. So yeah, it will take around 2 to 3 minutes possibly. Till that time, let's analyze our next file, which is also a machine learning model doing the same thing, nothing different. But the only tweaking that I've done over here is that instead of making the seed as 42, which I did above, now I have made the seed as 24. And by doing this simple thing, I got a different answer. We'll look into that. But first, let's wait for this code to run. So let's see. And with this single change in the below model, by just changing this seed to 24, I am creating a new run. So what is run and what is experiment? When you are making a machine learning model to predict something, you are doing an experiment. I chose logistic regression for my experiment. In that experiment, we have this over here as a matrix, and also, this values over here as a matrix. So if I change these values over here, I might get new predictions, and those predictions will be my runs. So this code right over here that you see is a new run, which can give a new output or predictions, which will be my area of analysis. So for the same experiment, you can perform 10 or 20 runs to analyze the best run. And then you will choose the best run or the best matrix over here, which is like, maybe your model is performing well with the seed 24. So you will choose this one. Or maybe your model is predicting well with the seed 24 and the matrix iterator as 90 and the rec param as 0.02. Maybe. So we will choose that run. What is experiment? When we choose a machine learning model, suppose logistic regression is not good and it gives you the output as, let's say, it will take around 3 minutes. I'm sorry. So let's say it will give you the output of area under the curve, as we'll see what is area under the curve after the code gets executed. For now, assume it will give you the area under the curve as 0.7. So it is predicting 76% values correctly. But what about my remaining values, which is my remaining 24% or somewhat like that? So what I will do for those values? Suppose I create a new experiment. This time my machine learning model will be naive Bayes classifier or random forest. And in that, I get my accuracy up to 98% with 13 runs, out of which one run outperformed all the runs in the naive Bayes classifier or random forest, having the accuracy as 98.5%. So now that's a different experiment with different runs and different parameters, accuracy parameters. And I will consider only those parameters which are giving me the high accuracy. So we can create such different experiments in the Databricks itself, or we can integrate ML flow to our code. And in this video, after I run this code, we will do that. So this video is going to be a bit lengthy, but we are going to cover up ML flow as well as experiment tracking in the Databricks itself, which will help you better understand about the real world analysis where you deal with multiple people, because over there multiple people can run the code, perform the analysis, do the experiment tracking, and it's not just you who is doing it. So your colleague is probably working on a random forest machine learning algorithm for the same dataset, and you are working on this particular algorithm, which is logistic regression. You both are performing several runs, and in the end you get to know that your colleague is getting good efficiency. So you will choose his experiment. We can automate this task as well, which is a topic of future. For now, let's just hope the model is run, and it is run. See, my accuracy is 0.7061, and then there is a big number. Around 70% is not good, I would say. The area under the curve is basically this part right over here that you see. And random guessing is basically when you get the area under the curve as 50%. Since we are getting a 70, it's better, not the best. Confusion matrix states that the true negatives that it tries to predict, that means the number of values which are not fraud, the transactions which were not fraud, and it predicted those transactions correctly, is 93,920. So it's a good number. For false positive, that means, what is false positive? When your label was not a fraud transaction, but it predicted it as a fraud transaction. So for that, it again gives a very fat number as 20,000. But in the case of false negative, when the transaction was indeed a fraud transaction, but it predicted it as not fraud transaction, we are only having a 77 values. And for true positive is when your transaction was a fraud transaction, and our model also predicted it as a fraud transaction, we are having 111 unique values. Okay. After that, you can see the area under the curve over here. And yeah, that's it. It's not a good model, still okay-ish for the analysis, still, because you are not dealing with a machine learning, I would say, understanding video. We are not like making the video to explain what is machine learning. We are applying the machine learning models to the real test. So it is obvious that you will not get the accuracy as 0.90 or 0.98, because this is not a data set which is set to give you that high number of accuracy. Okay. Now, after that small tweak, let me just copy this code right over here and paste it over here. And the only change I will make is I will convert this particular seed into 24. And let's see what I get in the end. So these are my 2 runs for the same experiment, which you can name as logistic regression. So for the second run, I have only changed one value, although I can change this matrix as well, the other 2 matrix which I have over here. I leave it on you because I'm lazy. So now wait for some time, let it run, and then we will analyze the output. So as you can see over here, we have executed the code, and what we are looking at is the area under the curve has reduced from 70 to now 67.67. And for the false negatives and true positives also, we are getting somewhat not good values. So yeah, we will not consider this run. Maybe we can try any other run, or you can try any other run which outperforms my initial run that I did over here for the experiment logistic regression. But guys, the question is that how do we track these experiments so that if your manager or your senior comes to you and asks you that, hey, can you tell me what was the outputs or runs for our logistic regression? I just want to check in, and maybe there is something that we can do about it. So at that time, you have to show him all the metrics. You can't run the code like this every time you basically want to check for it. So when you want to give the metrics, when you want to tell the person that, okay, this was my analysis, these were my matrix that I took for the consideration, and this was my predictions. Like my confusion matrix was like this, my AUC ROC curve was like this, and this was my AUC value, area under the curve. At that time, you don't show them the code, or you don't show them the files like IPYNB. You just show them the dashboard where you have all of these things saved. Greatly, we have a tool as MLflow, which helps us do the same thing. Although we have DVC as well to handle this experiment tracking, but still it's a very old industry tool. MLflow is something good to use. We are going to use MLflow with DAGSA because it's a free tool, although you can use it with AWS as well. Still, the main concepts will remain the same. So now let's try to see how to implement MLflow and integrate it with our 2 IPYNB files and create one more experiment with a new machine learning model and analyze both the experiments and all the runs that we have in those experiments.